my name's Evan, and today I'm going to be filming this engineer with me sort of video. And really, the reason that I'm making, or I want to start making videos like this, is because I've noticed that on YouTube, there's sort of a vacuum for a niche subject, which is long form engineering videos. I'm sure they're out there somewhere, but I haven't really been able to find any that I find interesting. All the sort of builder or engineering videos that I can find or maker videos, they kind of explain the rationale of the project and then they just have a quick montage and show the final product. But what I want to do is make sort of a more long form content showing all of my engineering decisions, my rationale, my justification, and especially when I get to something that I'm not 100% sure on, I want to show you guys what I'm looking at and researching in order to make that justified engineering decision. So a little bit about me. I'm actually a recent graduated earlier this month with a bachelor's of science in mechanical engineering and a minor in applied mathematics. I'm actually professionally going to be a biomedical research and development engineer. I start my job in a couple of weeks, so I have a lot of free time right now, which has kind of inspired me to take action on this. I really miss a lot of the engineering projects that I was doing during school, so I want to go ahead and take action and start doing something like this. And if it flops, it flops. But if you guys find this entertaining and find this long form content, something that's very intriguing, let me know below, and I can keep doing this. But yeah, so with that said, let's go ahead and get started. So as I'm sure you can tell by the title of this video and maybe the thumbnail, I recently signed myself up for a combat robot competition. It's called the Thoroughbred Beatdown in Ocala, Florida. I believe it's July 25th. So I'm currently filming this on May 31st. So it gives me a little bit less than 2 months to do this. I'm starting completely from scratch. I do have some inspiration and a few hand-drawn sketches that I'm going to be going off of. But pretty much it's a blank canvas. So we're going to go ahead and get started. So the first thing that I like to do, especially with a project like this where you have a limited weight, and therefore limited volume, I want to start by finding all of the pre-made components that I can find. So the reason I do this is because obviously if I'm looking at a motor that I want to buy, I can't control the mass of that motor, right? So that's something that once I select it, it's locked in. Okay, so a little bit of inspiration. Forget the name of the guy on YouTube who does Robotics, right? So he has this vertical spinning or vertical drum spinning, whatever you want to call it, Antweight combat robot that he calls Hotline. And from what I can tell in his videos, this thing's pretty successful. And I think he does a good job documenting, sort of how it's put together. And it seems like, at least at this time, these vertical spinners are winning the most in the Antweight division. So I definitely want to build a vertical spinner. It's probably going to be based loosely off of this. This is Hotline. You can see it has this, I'm assuming this is titanium machine spinner right here. It has these two forks in the front so that can establish the ground game. And then it has these two wheels right here. I'm not 100% sure how he's driving these wheels, but I'm sure we'll come up with a good way to do that. And so I can imagine that with this, he probably has either an aluminum or some sort of strong 3D printing filament, maybe PTEG or PTEG. And you can see here, he doesn't use a direct drive to his weapon, right? So he probably has some sort of brushless motor down here attached to this belt on this pulley that's spinning this. It says up to 36,000 RPM, which is pretty fast. This is kind of going to be my inspiration. I'm going to try not to look exactly at how he's doing this, although I can kind of see right here. Actually, I might as well learn from him. Where did that go? I might as well learn from him, see how he's doing things, and maybe understand, because he seems pretty successful with what he's doing. Okay, so here he has his I guess he's using two drive motors, sort of a belt drive system with these two pulleys, or these two belts right here. This is attached to the opposite through an axle right there. Cool. Okay, yeah, I think we could definitely do something like that. And this does look like some sort of 3D printed material. I kind of want to go with sheet metal or sheet aluminum, and I'll probably just outsource that to Cut Sind. although I do kind of like the carbon fiber plates down here. I think it's really just going to come down to how much weight we want to use. I've seen a lot of people using TPU as a material, and so I do kind of want to use that as a sort of outer shield to absorb some of those bigger hits. It's like here you can see this vertical spinner is using TPU, where you would expect the weapons to kind of make contact, and I think that's a really good idea. So just depending on the weight limit, I do want to I do want to eventually incorporate like a TPU outer shell. But for the most part, this is going to establish our design. And so I do want to write a couple of requirements just based off of this, really simple stuff. I don't think I'm going to go do any research and figure out like actual numbers, but just to give myself a little bit of guidance to, have somewhat of a proper engineering process. So the robot shall weigh less than 450 grams. I know that's technically a volume, but we're not going to get specific. So the robot shall have a vertical spinner. The robot, maybe a little bit for the power budget, shall have a battery life capable of, let's say, 2 full matches. And if we find out that whatever lipo or sort of battery we're using can only supply 1, then we may be able to change that requirement. But we'll get to that when we get to it. If anything, we can just make it really easy to access, and so we can change the batteries. So yeah, and we'll say the robot shall have an outer protective layer of TPU with a thickness minimum. We'll say a minimum thickness of. It's hard to tell with the weight limit because I know TPU. I feel like it's probably a bit of a denser material, so I don't want to give too much to it as far as weight. But we'll say a minimum thickness of 5 millimeters for now, and these are subject to change. So obviously not doing a ton of proper requirement typing or writing right now, but I do just want to have this to sort of get in the habit of establishing requirements. So let's go start looking for components. So the first thing that I want to do is select the motors. We obviously, I think our drive motors and our weapon driving motor are going to be our probably 3 most important components, as that's what's going to help us one, move our opponent, but also inflict damage. So look up Antweight combat robot drive motors. So I do want to end up using a hub motor for the weapon. Oh, this is nice. So they sell weapons as well. That actually could be pretty useful. I kind of like this one. I'm assuming that's inches, 3.25 inches in diameter. That could be pretty helpful. If they don't have the exact size we need, I'm sure we can get something cut out of steel or maybe machined out of titanium, depending on how much that costs on Send Cut Send. But I just want to kind of look through here and see what our options are. Okay, good to know they have a titanium wedge. That might be good later on. Let's look at these. Mini brush MK2 Antweight planetary motors. Okay, so they have a 3 millimeter shaft and a 4 millimeter shaft. I'll probably end up going with a 4 millimeter shaft. It looks like these have a knot, like a little D shaft or notch on them, so we can put the wheel on there. I'm sure. I wonder if they have a interference suggested fit. Okay, cool. So they have the weights here too. 16 millimeters. Okay, not yet. So it does have a gearbox. I do think that a gearbox would be really nice here. Obviously in the Antweight division, you're gonna have a smaller arena, so you don't need a ton of speed to sort of get around quickly. And I do think that in this division, especially, pushing power or pushing strength, whatever you want to call it, from the drive motors is going to be extremely important. So I want to make sure that we're probably converting some of that speed towards torque, right? So we do have a 22.6 to 1 planetary gearbox. I do like the fact that it's planetary as well. Okay. Comes ready for combat, sure. Okay. Okay, here's what I think is going to be most important. 12-volt input, or 12-volt input, 3 in series, 2 amp stall current. That's your stall torque. Okay, so this is going to be really good. This is really good information. Most of my work that I've done in robotics, that is probably the most important information when it comes to motors, or at least when you're trying to integrate motors with your electronics and your mechanical design. Oh, great. So they actually attach a CAD model. So I'm going to go ahead and copy that. Just paste that in there. Cool. And I think that using OneNote or anything like that is a great way to kind of organize your thoughts. I'm also a big fan of sketching out what you're doing as you're going, so that you're not limited to your knowledge of the CAD software that you're using. I won't be doing that today, and I will be using Fusion, which I feel like I'm pretty good at, so I don't think that I'm limited by that in any sort of way. But yeah, so we have those motors selected. I'm going to go ahead and download. Now I'll download that CAD model later. But what I like to do is sort of make or what I'm going to do is make a top-down drawing of how we're going to arrange all these components within Fusion. So I sort of have all my hotkeys laid out already. And the first thing I'm going to do is sort of create a sketch of this from a top down. So it's millimeters. Looks like 36.1 by, what is that, 15.5. So we'll go 36.1, oh, I'm sorry. And then our shaft length, we'll go with, is there a price difference here? No. We'll go with the 3 millimeter. This is the same. Yeah. Yeah, just to save a little bit of weight, we'll go with the 3 millimeter shaft. Or what did I select earlier? No, we'll go with the 4 millimeter, whatever. So I'm going to then use a midline to get to the center of this rectangle that we already drew. So I've been using Fusion for a really long time, and it's gotten to the point where I don't even know if the way that I'm using it is correct anymore. But I know that pretty much anything that I can think up, I know how to get there. So like you can see like the way I'm making the shaft is probably not correct, but I just want to make sure that I'm centered correctly on that midline, and this is the way that my brain just wants to do it. So yeah, and then I'll go ahead and trim that line right there. Sure. And let's see, do I want to dimension all of this? Not really. It's probably bad practice, but whatever. Okay. All right, so it's starting to come together. We have our motor here. I do want to draw a midline that we can reflect this across. Let's see, so we're going to have wires coming through there. I want it to be symmetrical about the middle, just for weight distribution. So just do a construction line parallel with this center line. I think I'm going to go with 2 centimeters in clearance there. 2 centimeters. Oh, but I want to mirror it, so we're going to go 1 centimeter. draw another center line. And this is what we'll mirror our sketch across. So create, mirror, mirror line, bang. Sweet. Okay. So now we have our motors laid out here, and I do want to just measure this in a pretty rudimentary way. So we're looking at about 16 centimeters. That's kind of what I figured. I figured we would end up having a kind of a square design, maybe 15 by 15 or 16 by 16. It looks like with all of our frame and stuff, it might end up being 17 or 18, but that's fine. For now, I'm not gonna get too caught up with that. Okay. So the next thing I want to do is, we really should do our battery now. I say that, I think I'm going to end up just doing like an electrical bay, if you will, over here, and probably create some sort of custom battery arrangement to fit that, rather than buying something pre-bought. That way I can have a little bit more creativity with how I'm doing this. I am being a little bit lazy right now. I probably should establish some sort of power budget, but I'm not. But, considering a million people have probably made Antweight combat robots before, and they probably use 2 of these motors and 1 hub motor, and they all use the same receivers and controllers. I'm not going to worry about that right now. I'm going to assume somebody's done it already. I will also be able to figure it out down the road. So, but for now, we kind of understand our width, and I do want to I want to go with a square design, just so it's a little bit more stable and easier to control. So we'll go with the center rectangle, and I'm going to make this a construction line, because I'm not married to this design yet, but let's see. So that's 16 right there. We'll go 17. Give a little bit of leeway, because I'm not 100% sure. Oh, actually, with that, what is that? Sorry, I don't remember what project that was from. But with that 5mm TPU shell, let's go 17.5. Oh, cancel. Control Z. Sorry about that. First time doing this. This will not be polished, but I do just want to get in the habit of making videos like this. Because I really do love projects like this. I think that this is, sorry, I said 17.5mm or centimeters. Sorry, I'm all over the place. Golly. Sorry, trying to think about what I want to say to you guys next without actually, and then trying to make these sketches at the same time. I do think that doing projects like this is becoming ever more important, with sort of the advancement of AI and how addicted everybody, especially my generation, I'm 22, and my generation is to social media. I think it's so easy to become a consumer of information and media rather than a creator. Even in your own projects, you'll find that, or at least I find that the what's the word? The pressure to use AI in order to do what I want to do in a quicker way, so that I can achieve more, right? Consume more information that AI is giving me. It's very high, and it's really hard not to, honestly, especially as an undergraduate and as a student athlete. You're so limited on time, and everybody wants to do so much that if you can do things faster, it's better. And I don't know if that's always true. I think that you become a more intelligent person by taking your time with projects like this, by avoiding the use of AI and things the old-fashioned way. Now, that's not to say that I don't think AI has time and place. I think it's an incredibly powerful tool, right? Maybe to use in the workplace or, I'm not 100% sure, but I do think that's a powerful tool. But I also think that it's so powerful that if you give it the ability, it will rot away your ability to create things, right? It'll rot away your ability to make critical decisions. Just the same way that social media will rot away your attention span, I think AI will rot away your creativity and sort of your self-sustain or your self-reliability, right? So it's kind of my spiel on that, but yeah. Okay, so back to it. We have our motors now. And I'm going to go ahead and start sketching out the frame. So I want to use, I mentioned earlier, I wanted to use sheet aluminum. This is going to be really light. Not 100% sure what gauge I want to use yet, though. So I know I am going to outsource this to Send Cut Send because I don't have a way to cut aluminum. So I'm just going to look up Send aluminum. We'll go 6061 for now. So I'm going to gauge thicknesses. I have no idea how thick I want to go. No idea at all. But I do know that I want it to be definitely not close to 2 centimeters, probably about a little bit less than 3/4 centimeters. I'm not 100% sure how to justify that though. Let's see. You're gonna see my engineering inexperience because I am a recent grad, so I have a lot to learn. But how to determine engineering, or how to determine necessary sheet thickness. Yeah, so it's obviously we refer to the requirements. We don't have any structural requirements. If I really wanted to, I could find the mass of this, right? Understand that it's going 3,600 RPMs or 36,000 RPMs. End up calculating the force that it would output on, say, making contact with an aluminum frame, and then find what necessary thickness I would need so that it wasn't, substantially bending that aluminum. But I'm not going to do that right now. But what I will do, I promise to do this and I won't be lazy, is I will select a thickness on probably the thicker side. And if it ends up that I need to eliminate some mass from my end product because I'm over my mass constraint, then I will run FEA, finite element analysis, on this frame, simulating something like this, hitting it, to understand how that thickness is going to absorb that or react to that force. And so I really do think that if I have 1/2 centimeter, maybe 3/4 aluminum, 3/4 centimeter aluminum, acting as this frame right here, it's going to be more than strong enough to take that impact, especially in the Antweight class, which is why I'm not too worried about what I pick here. So let's go ahead and look. Yeah, I know I just had that whole spiel about AI, and then I'm using the Google AI summary. So let's go to sheet metal, gauge, size, and chart. Okay, so aluminum, inches, millimeters. We'll go in millimeters. For some reason, my brain just works better in the metric system, even though I am American. I do want to go 6061. Closest to 7 millimeters at 6061. 2 millimeters. Okay, maybe 7 is overkill. 7 millimeters is definitely overkill. I don't know what I'm thinking. We'll go with this. This looks like it's 1/8 inch. Sure. So that's what we're going to go with. And also they have different alloys there. That one has the most options. So if we want to go back and change, because this might have a slightly lower density and might give us some sort of attribute that we want later on, we still have that ability. But I'm just going to, for now, go ahead and put that in the OneNote. All right, we're getting somewhere now. So now I understand the thickness of that, and so we're going to use that for our rails here. So let's see, what was that? 1/8 inch. I'll be able to remember that. So I'm going to go ahead. You're about to see the sort of roundabout way that I like to use or make sketches. So even though this is 1/8, I'm going to go 1/4 because I'm using a center point rectangle, right? But it's right on the face of that motor, right? So I don't know if I want to go all the way. Well, we want our wheels to be in a square form, so yeah, I will go all the way there. Let's see, 1/4 inch. Oh, this is length. I'm being an idiot. All right, so it's going to automatically constrain to that 17.5 centimeters that we set out earlier. So I'll go to the other dimension, and I'll do 0.24 inches. Right, okay. And then what I'm going to do is I'm going to draw a center line. Here. Sorry, I'm on the wrong type. Wait, what is this? Construction. I need a center line. Right, and then I'll do a real line, kind of overlapping that. And then so what I can do is I can use my trim tool, sort of trim that fat. Oh, I picked the wrong one. I didn't want to. T. Okay, fine. Yes, thank you. Am I using sketch the proper way, or the way that they intended? Definitely not. But that is okay. Okay, so now we have sort of that sheet metal cutout that we're going to do from our top-down view, right? And so the first thing I want to do is, if we go back and look at Hotline, you see these metal or these frames, right? It looks like he 3D printed those. We're using aluminum, but that's what I'm creating right now. Tab, I'll go point, what was it? Oh, right, 1/8 inch. Perfect. All right. Guys, this is coming together. And I saw these as we were looking through earlier. Oh, no. Uh-oh, I just closed out my OneNote. But as I was looking through the Repeat Robotics library or catalog earlier, I saw these. Gold clamp hub for custom wheels. Okay, that's not what I thought it was going to be. Gold screw hub for custom wheels. No. What I'm looking for is some sort of hub in order to attach these aluminum frames together. And so here we go. Something like this. Yeah, this is actually perfect. 25 millimeters. Yeah, this is perfect. So this is exactly what I want to use in order to attach my aluminum frames together. So I'm going to go ahead and CAD that up. And so that'll go in these corners, right? Now I'll do that later. We're rolling right now, but I am going to use that thickness. Okay, so we have that 2.5 centimeters, right? I'm going to go ahead and finish this sketch. And right now I'm just going to extrude where that frame is, right? We understand that that motor is going to be in the center point. So yeah, we did all those sketches just to have this. But we're going to go 2.5 centimeters. Oh, that's 2.4. Okay. Here we go. We're working now. And what I'm going to do is I'm going to go download the CAD model for this. Do they have a CAD model? Yes. Awesome. Wonderful. Download file. Okay, while I was browsing through Repeat Robotics, I also found these aluminum hub motors, and so I am going to go ahead and get one of these, because it looks like you can go direct attachment to the motor, which is something that I want. I don't want to add any unnecessary parts, and I do think we'll get much stronger hits and much stronger collisions if we go direct. Let's see, do we want red, black, raw? Oh yeah, I definitely need the hardware kit too. Okay, this is definitely coming out to be expensive. We'll go with the black beater. Maybe red. I'll decide that later. But I am going to go ahead and download the CAD model. Is there no CAD model? I would really like a CAD model. Is there a technical drawing? Here we go. Here's the CAD model. Nice. Okay, and then the last CAD model that we're going to need. Man, they have everything that you could need. Antweight aluminum hub motor. Oh, it might be cheaper to buy that. Aluminum hub motor. Yeah, it's definitely going to be cheaper to buy this. Gosh, I am definitely being a little lazy right now, but no, those hub motors cost at least probably about $30. The beater's $30. Then the assembly kit is going to be another $20. I do think I'm going to save a little bit of money here when it's all said and done. And I think I definitely like red. Red's more dangerous. So, okay. Okay, so now I'm just kind of making a little bit of a rudimentary bill of materials. I wanted to create a table, but I think because I'm screen recording, it's not letting me really do that. So first thing here, I'm going to use these. So this is a 2-pack. So let's see, 1, 2, 3, 4, 5, 6, I'm just counting the corners. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, not 9, 10. 7, 8. Yeah, we're gonna need 8 of these, so 4 packs. So what is this called? The nut strip. Okay. I'll paste the link there, and then our price. This is definitely not how you should do a BOM, but just for the sake of the video, that's what I'm doing. I'm just gonna do the total price. So 4, 2-pack, we need 8, so $16. Okay, Next thing we looked at was this. I'm going to do the Antweight aluminum hub motor beater bundle. I am going to go in red. Is red still $79? Oh, red's $81. That's fine. And then our motors, I believe is the last thing we're going to buy from Repeat Robotics until we get to the electronics. Oh, this is for one, so I'm going to have to buy 2 of these for 20 bucks each. They're definitely scamming. They're not scamming. I take that back. They're probably a really good company, and I've heard some good things about them, but they do have a little bit of higher prices. But I think what I'm paying for is, I'm getting a good deal. And I think these are pretty high quality components, so I'm happy to pay for that. $40. Yeah, so this is climbing quickly. This is climbing quickly. But we'll figure out how to reduce prices later. For now, I just want to go. Okay, so now I'm just uploading all of the CAD files that I downloaded. So we have our brush motor, 4mm shaft, our hub beater assembly, and then okay. So now we have those sort of side frames that we made. Pretty bare bones at the moment, but we'll get to that. And I went ahead and got these CAD models so we can start sort of putting together an assembly. We'll convert this. So I don't like the Fusion update that they did a couple months ago, where you have to set a file as being a part, an assembly file or a hybrid file. I'm sure there's valid reasoning for that, but the way that I learned to use Fusion, and as I mentioned earlier when I was doing the sketches, I don't know if I do it correctly, but I've always just made parts and then I turn them to components when they're ready to be components. But that way I'm able to reference components to one another as I'm building my assembly file. It's never made a lot of sense to me to create a component in one file and then drag it into another file and just keep referring back to the dimensions, or I don't even know how you would do that and make the parts align, right? So it makes a lot more sense to me to just always use the hybrid, as they call it, the hybrid files. Okay, so here we have our motor. Right now its material is just steel, just so I can differentiate it from these aluminum components. I'm going to go ahead and assign it a material. So modify material. Forgot that I had the shortcut U there, and we'll just make that. Okay, it probably doesn't matter. Let's see what looks cool. Metal. Actually, I should definitely just do appearance, not material, so it doesn't. So I can still reference properties because I'm just gonna. Because I know the weight of that. So we'll go metal coatings. Oh, this black oxide. I like to do this just so that I can see what different components I have going on. There's definitely some more tenured engineers watching this and shaking their head, knowing that I'm just doing a million things wrong. But I'm an entry-level engineer, and so I'm learning. So yeah, I'm going to go ahead and joint that right there to this aluminum, and we'll go ahead and assign the aluminum there. And I'm seeing that this is 2 separate parts in one, or 2 separate bodies in one component. I'm fine with that for now, just because part of me wants to just copy and have the same component just copied over. but I know that this one's probably going to have different fastening holes in that one, so I'm going to leave them separate for now. So I'm going to turn visibility off on that one and get to work on this one. So my favorite tool in all of Fusion is this project tool. So I just press P, and I can project this face, and God, that's so easy. And now I have that sketch. I can just go offset, give a little bit of a clearance here. We'll go 0.5 millimeters, perfect. And we'll do 0.25 millimeters. Now, what's really going to constrain us is Sincutsin's sort of manufacturing tolerances. But I gotta imagine they can get it down to 1/4 millimeter for sheet metal. What's going on here? If my employers are watching this, I would definitely take more due diligence for you guys. But since this is just kind of a hobby thing, kind of being a little bit rough around the edges, which I'm sure it'll be okay. And then we'll just extrude this all the way out. Just make sure it's only cutting that one body. Okay. Perfect. Look at that. All right. And I'll go ahead and do insert fasteners here. Oh, there it was. Insert fasteners here, just so that I can, when I go ahead and make these wheels, I can see how much room I'm going to be working with. I don't think I want to do countersunk. Probably want to do something small, like flanged. Probably doesn't even matter what I select right now, because I'm going to end up doing something different later when I actually look into buying these components. But we'll go flanged. No, I don't like flanged. Definitely use round head. Most likely use a hex socket. Okay. And just put that bad boy. No. That's way too big. Wait, no, what am I talking about? Yeah, it is way too big. Auto M3, can I not go smaller than that? What's the diameter of that hole? Close. Hold on. 2 millimeters, and it's pretty small. I may have to attach these motors. Let's see, are these tapped? I can't tell. It doesn't say. Much trouble, not with the squeeze. Okay. Alright. Yeah, that'll do for now. So now I'm just placing this this weapon, and I want to orient it vertically because I feel like that's going to be the more constrained space. Obviously, I don't want it dragging on the ground. Doesn't really matter where I insert it right now. I'm eventually going to joint it to part of this, but just to visualize this right now, because I want these bolts right here. Now I want this plate to screw in or to fasten to this, right? So this isn't going to end up being rectangular. I'm going to end up having sort of like a curve up here, if you can visualize that, that's going to hold this. right? But just for visualizing right now. Okay. I do want this. What am I looking at here? Okay, that's wires. Okay. I just wanted to see that. So go ahead, do that. Let's see, this has a diameter, outer diameter of 3.6 centimeters. So what I'm going to go ahead and do, the question is how much overhang do I want to have, right? So if we were to do so what I'm going to do is I want to constrain this vertically or horizontally with the front of this frame. Right, and then definitely didn't do that right. I'm going to go dimension, yeah, there you go, 0. Why can I not do 0? Okay, that's going to be fine for now. And vertically, I'm going inspect from there, kind of the outer diameter is 6.4 centimeters. Okay. So that means since we don't want this on the ground, but we want to get it as low as possible so that I can get under other opponents, we want that. So half of 6.4 centimeters is going to be 3.2 centimeters. I want to, just to be safe, I want to give it about a half centimeter clearance from the ground. So 3.2 centimeters, 27. Okay. Now you got to figure our wheel diameter is going to overhang probably by at least 3 millimeters. So right now we're looking at 32 millimeters because that's half of this diameter, minus, you want to have a 5 millimeter clearance from the ground, so 32 minus 5 is 27 millimeters, but your aluminum frame is going to be elevated by 2 millimeters from your wheels, so you add another 2, so that's 29 millimeters. Please correct me if I did that wrong. That doesn't look right at all. This looks way bigger than that. Did I measure that right? Okay. Right, okay. Outer of 6.2, of 0.62. Divide that by 2 to get your radius. You get 31 millimeters. So 30 millimeters up, it's going to be grazing, 31 millimeters up, it's going to be grazing the floor, theoretically. Add 5 millimeters clearance, so 36 millimeters. Plus 2, 34. Okay. I don't know how I got 29. Sorry, guys. Okay. So what I'm going to do is I'm going to make some tangent lines. We'll go constraints, tangent, nice. And then just to give this a little bit more shape. Oh, okay. I was doing it from the center point, and it needs to be. We'll go to the midpoint there and set it up to be tangent. It's looking pretty good. That'll be on this face right here. As we did a circle. It's awesome. I just want to see something real quick. I'm trying to understand if it needs to be flat to this face or how this fastening system works. Let's go back. Let's go back to this hub motor kit so I can get a better look. Do they have like an assembled video? So it seems like it, if you look here, where am I? Oh boy, okay. If you look here, it seems like the only thing fastening it to the rest of the assembly is this one bolt here that's kind of connecting to the axle. And then so this plate is used to fasten to everything else. So our plate should fasten to that plate, but still have a through hole, allowing this bolt to go through into this axle. So we're going to create another sketch on here. We'll go project. You know, I love the project tool. And I'm just going to hide this real quick. It's an interesting shape. But I'll go ahead and give that millimeter clearance. And give the rest of these 1/4 millimeter. should be accurate. Turn that back on. Sweet. Okay, the next thing I'm going to do is bring in these nut strips, and they were like a anodized blue aluminum, I believe. Let me go back. I don't know what material they were. Yeah, 6061 black. Okay, we'll do that. So I'm going to edit the actual part so it's not just in the assembly file. Modify material. Oh, I'll make it blue for now. Oh, wait, oops. Guess I gotta do the appearance as well. We'll make it black. That's what it is in real life. Okay. Back to our assembly file. Update this. Sweet. I want to have 3 of the holes attaching it here. Flip that. That's 2. So, what do you think about this? Yeah, so I want to hit this corner right here. If you're still watching this, you're different, that's for sure. Brother, I don't know what I'm doing wrong here. There we go. Okay. Now I'm just going to duplicate that a million times. Just kidding. Okay, so we're running into our first kind of issue here using these nut strips, right? So it's going to run right into, so you can see, sort of this plate that our weapon is attached to. So I'm wondering if I want to move this up, add a little bit more clearance to the ground, or from the ground, right? Because we're going to have those, we're going to end up having ramps at the front of it that will guide any opponent towards our weapon. So I'm going to go ahead and do that, and I really wonder if I can just edit this sketch and change that vertical constraint, or no, sorry, that's not what I meant. Which sketch was it? Was it this one? Yeah, I think it was. And is this constraint right here? So if we give it another centimeter, that would be 44. So let's see how that affects everything. And it does not, did not like that. But it does look like that would fit. We're going to go with a little bit of a kind of a jank fix, but it should work fine. Yeah, so that's tangent. Bang, 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 entering flow state. B, P, sorry, P, okay. We'll turn off visibility to that. No, not that. This. Oh. 1mm. And all this is going to be fastened anyway, so as long as there's enough room for the bolts to fit. And I'm going to go ahead and copy that. Actually, I know an even faster way to do this. I'm going for speed. Go through, and then I want to use the hole tool. Turn that sketch back on for me. Hole. 1, 2, 3, 4. And so we want that, oh gosh, what was this diameter? Jeez, okay, maybe I'm not saving time that way, but 3mm, so we want it to be 3¼ Fast as hell. Not really. Oh boy, it's coming together. Put this last block on. Yep, thank you. Flip. Yeah, this is going a lot longer than I thought it would, to be honest. I thought I would be here in about 30 minutes, but I mean, gee, that's just how life goes. Especially engineering stuff without proper preparation. And now we're having some sort of extrude issue there. I don't know what's going on. $3mm, and this is supposed to be what? This happens sometimes. I do want to end up adding a. Let's change that. Okay. Nope. I mean, sometimes I'm sure I'm doing something wrong, and I've noticed specific issues come up with the way that I do things in Fusion, and I have to find like dumb little fixes like that. So what do I want this radius to be? 4 centimeters maybe? No. Let's drag and see. Yeah, I kind of like that. So 40 centimeters. Yeah, that looks real nice. And for the rest of these corners, let's go ahead and do, well, maybe not, because those are going to be concealed by this back plate that we end up adding. So I think we're good for now. Okay, so one issue that I am noticing, and I don't think, God, this is a dumb issue to have. I'm going to have to move that motor. Right, because if we have that other plate mounted here, those motors are definitely going to interfere with each other. So what I'm going to do is I'm going to move this motor towards the front a little bit so that on the next piece that we create, we can kind of have them stacked next to one another. Shouldn't be a terribly difficult change, but we will see. So I'm going to scroll my timeline all the way back. I don't remember what is what. Oh, definitely this one. So we're going to edit joint and move it that way. Yeah, 2 centimeters. Bang. Bang. Yeah, it's easy, right? And so now, from our midline, on the next one, when we mirror this over, we'll have to move this 2 millimeters in the opposite direction to balance things out. Maybe not. I don't know how much the balance of those motors are really going to affect things. As long as they're driving the same, it shouldn't be a big deal. Okay, I'm going to go ahead and make this a component. Create components from bodies. We'll call this side frame left. From the perspective of the robot, that is the left side. And we're going to go ahead and move that over. Nope, hold on. But I want to create a copy. No, that's not how I want to do that actually. I have a better way to do this, so it'll be its own component, and yeah. Okay. So I'm going to project this whole thing. Okay. Bang. And then because we moved that, it's 8 millimeters. I want to move this over 4, so it'll go right over. No, it's not going to work, is it? But we know that that's 8 millimeters, so we're just going to create a line, construction line. Yeah, here. 4 centimeters. Okay, I'll go create a circle. Not a construction line. 8 millimeters. And then I want to know the length from here to here, 5 millimeters. And this is 2. Okay. L, construction line. Yeah, this is not the right way to do this, to be 100% honest. Because if I were to go and change something about that original one, it would not change, it would not update this. But, oh well. Yeah, see, I'm already doing something wrong. 8 millimeters. What am I doing wrong here? 5 millimeters. At some weird angle. Okay, that's how we're gonna do this. So let me. Okay, sorry. I'm rusty, guys. I'm rusty. Almost like that, that. Create a copy. We're gonna move it 4 centimeters. Nice. All right, and if I remember correctly, we wanted to make that 3.264 millimeters towards the motor. Bang, there we go. And then currently that's a body, make it a part. Create components. We'll call this side frame right. Curious as to where we are on our weight budget right now. I'm a little worried. I mean, obviously, like right now, we're not going to be over, but I don't know how we are on track. Looks good to me. Now, if we compare to this original sketch where we outlined. Okay. So I do think that we can make it a little bit shorter from the back to make it a little more square. Well, it's going to depend on the length of those belts. We'll keep going for now. Probably should have left that on the entire time. And we could make this a lot skinnier, but because we have this hub motor selected, we'll leave it for now because it's going to be the right width for that. So here we go. We'll create a mid-plane between these two. Okay, make this. Then we're going to mirror this and all this. And I think that back here we'll have our sort of electronics box, and that will definitely be enough space for what we're doing, and then everything else will be used for our drive system, right? So this is really coming together. I'm going to go ahead and make this front area, right? So let's make the back first. So what I'm starting to realize is this is becoming more of a CAD kind of walkthrough and not so much an engineering walkthrough, which I'm becoming a little bit regretful about, because I do want like the rationale to be there, and I'm mostly just kind of flying by on this and not giving my reasoning for what I'm doing. But you know, this is take number one. So I think what I'm going to end up doing for these front plates is I'm going to have an aluminum plate cut out there, and then a TPU cut out almost like in the shape of a wedge, and we'll have those hooks coming out of the wedge. But for now, let's do this back plate. So create a drawing here, and we're going to project all of these. We'll give a, why is that not aligned? Oh, probably is aligned, but oh boy. Okay, we're gonna have to make these. So it looks like that. Okay. Let me go reference that drawing and see what that dimension is supposed to be. So that is supposed to be 6mm diameter. So I want to give it 6.5. But it's kind of hard to center. Right, because 6.5, that don't look right. That do not look right. I don't believe them. Alright, so what I'm going to do is, because I have a drill press, I'm allowed to just make this as is, and if I end up needing to kind of flesh out some of the holes a little bit more, I will do that. Wonderful, wonderful solution, I know. Would this fly in industry? No, 100% no. That's okay. This thing's going to end up getting destroyed anyways. Well, hopefully not too destroyed, but it's going to definitely take some damage. Remind me the thickness one more time. 3.264 millimeters. Oops, messed that up. Oh no, attached. I don't want to do that. So the reason it's attached because I use this join, and I should change it to a new component. Yeah. So now I'm going to extrude those holes through, and I want to turn visibility off for that, and project that, and that. Okay. So now when I come back, we're just gonna have to do this the old-fashioned way. We're gonna go 6 millimeters. It says 6, but I don't. We'll go 5. 4.5. Okay, so now we can just select all these holes, extrude them through, and end up adding our backplate. Make sure we're only cutting that one object. Wonderful. There we go. There's our backplate. This is coming together. Yeah. Okay, I want to go ahead and see where we're at with mass. So I'm going to assign all of these the right materials. So we got to figure out what material I want that to be. If we go back to our options, we have 5052, 6061, 775. I definitely want to go 775. And the reason is that's most durable and I believe most abrasion resistant of the options. So just confirm that. Oh, okay. Possesses poor native abrasion resistance, especially in T6 tempers. Has high strength, highly susceptible to wear and scratching. Okay, but if you recall, okay, that's fine, because if you recall, we want to have this TPU layer, right? So ideally, this thing's not going to be getting scratched much, and if it is, it doesn't really matter. But because it's renowned for its high strength compared to 6061 and what was our other option? 5052. That's what we're going to go with. So 775. So 775. I should definitely know that off the top of my head, but it's been a while since I've selected materials for anything. The last thing I did was my senior design project, and we made most of those decisions just based off of what was available, to be 100% honest, even though we wouldn't tell our professor that, but yeah, it's true. So having the actual options now it's pretty cool. I already know the most CAD intensive portion of this entire thing is definitely going to be the drive system, because we're going to have to figure out the length of those belts. That'll determine the positioning of these wheels, because I want to get it as wide as possible to stay within that square that we gave it. But obviously, I don't want to have to make my own belts. Although I could print them from TPU. But I understand that if I buy one, it's probably going to be much stronger. Alright, and I believe this was 6061. Modify physical material. Set 75. 60. And those motors were 6061. Oh wait, I need to go to the actual this thing. And because I don't know, I want to assume worst case scenario, so I know that most of this is going to be, it said 6061, but it's probably the outer shell. But we'll make this outer ring 6061. Yeah, I don't want to make too many assumptions, so steel's going to be really heavy though, so. Oh wait, we know the weight of this, so it doesn't really matter too much. So let's go ahead and do a sort of just a sanity check on our mass. So let's go up here. So we know that hub motor, all that's going to be documented. So we have 8 of these, right? And they are 2 grams each, assume worst case. So, wait, 2 times 8, and that hub motor, we'll do everything in grams, by the way. Sub motor is 98 gram, 144. Jeez, it's not light. It's definitely be easier to do in Excel. And then those motors, I want to say those were 12, but let's double check. We did the 4mm. What millimeter shaft did we do? It's not very helpful. I think we did 3mm. No, it says here. We did 4mm. And 27.5 times 2, 55. Oh, brother. So we're already looking at 160 plus 55 is 215. Okay, so we're pushing on halfway there. That's not including any of all this. So there's a chance that we're gonna have to shrink this down. And so what I would end up doing to make that process a little quicker is I would remove this fillet, add a plane here, extend it out, cut this, right, extrude these pieces back, move this forward the same amount, and then use the combine tool and kind of link those back together. But I'm going to leave that for now. Alright, I think that's where we're going to leave it for today. I feel like we're in a pretty good spot, so let's just take a look at it without the all the construction stuff. Objects visibility, all work features. have to end up adding our fasteners here. They're going to go that way. Oh, and that's extruded all the way out. Fun. But yeah, no, I feel like we're in a pretty good spot. So thank you guys for watching, and if you like this long form, I'm sure it was not very entertaining, so it was pretty dry. But yeah, let me know, and I'll keep making these. Thanks, guys.